So we're about to start Unit 2 about what we call differentiation, which is a fancy word for the process of finding derivatives. This is our first of several units on derivatives, how we can find them and what they can be used for. We're going to start by looking at section 2.1, which is an introduction to differentiation. I'm going to try hard to go slower than I did in Unit 1. But again, like I said then, without a class in front of me, it's a little bit tricky to know if the pace is right or not. So please do continue to make sure you're pausing the videos if things are going a little bit too fast. But an introduction to differentiation. To get us started, this is not 100% accurate, but it's a decent place for us to start. We are going to say that the slope of a curve is the derivative. 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 We're going to refine this definition, not even calling this a definition, refine this idea in a little bit, but this will be a decent place for us to start. We have a symbol for finding the derivative. If I give you a particular function, f prime of x is our symbol for the derivative of a function. And this x value is the x value where we want to find the slope of our curve. That is the x value where we're finding the slope. F prime of x, the x is just the x value where I want to find the slope of my function. This will make a whole lot more sense with an example or two. So can you take out the worksheet titled Section 2.1, Intro to Differentiation, Graphical Examples. So we have the function f of x over here. I want to find f prime of 1/2, f prime of -2, f prime of 5, f prime of 0. I want to find the slope of this thing at various x values. Well, let's get started. F prime of 1/2 means when x is 1/2, what is the slope of this function? And actually, this is not a terrible one to deal with because this piece over here, surrounding x equals 1/2, is just a line segment. So to find the slope at 1/2, I can really just find the slope of the line from 0, 2 to 1, -2. I'm just going to use my normal slope ideas from Algebra 1. -2 minus 2 over 1 minus 0 is going to give me -4. Guess I didn't even really have to use those numbers. I also just could have counted a rise and a run. I was rising -4, I was running 1, slope is -4. We just found our first derivative. We just found the slope of a function. Not a big deal, well, especially in this one when our function is just made up of little line segments like that. How about you take a moment and see if you can do letter B, f prime of -2, the slope of that function at x equals -2. Okay, well, at -2, I'm right over here on this line segment. The slope of that line segment, well, rise of 2, run of 4, so 2/4. But of course, you shouldn't call it that. We should simplify our fraction, and we're going to get 1/2. How about you try f prime of 3? No, sorry, f prime of 5. Okay, so f prime of 5, I want to find the slope of this piece over here. Looks like a rise of 4 and a run of 2. I think our derivative at x equals 5 should be 2. One more for you to try. How about f prime of 0? F prime of 0. Okay, I want to find the slope of this thing at x equals, okay, Well, looks like I kind of have two slopes. I have a slope of 1/2 ending there, a slope of -4 starting there. But right at 0, what's the slope? Yeah, you can't talk about that. We don't actually have a slope at x equals 0. We have to say this derivative is undefined. Or the derivative doesn't exist. I'd take either one of those. So this is our basic idea. We're trying to find slopes, and it's not difficult when we want to find the slope on a piece of the function that's a line segment. If the function is a curve, it's a little bit more involved, and I think I need to give you a better definition of the derivative than just the slope of our function. Here's our better definition. Definition. The derivative f prime of x gives the slope of a line that is tangent, touching in just one point, to f of x. The derivative, f prime of x, gives the slope of a line that is tangent, just touching, to f of x. If you need another moment, please pause the video. But then I want to go back to that graphical example worksheet, and I want to take a look at number 2, where I can't just find derivatives by counting rises and runs, because I have a curve rather than something made up of line segments, but I can still try to find some derivatives. What I'm asked to do is, this is the graph of f of x, and I want to put these 5 derivatives in decreasing order, so from the biggest derivative down to the lowest derivative. First of all, these derivatives represent the slope of a line tangent to my function at various x values. Well, let me draw in those little tangent lines. At x equals, well, a, tangent line looks kind of like that. At x equals b, tangent line's going to look like that. X equals c, just touching the function, like that. X equals d. And e. Make sure you're drawing in those little line segments that show our slope of a line tangent, that show the derivative. Okay, well, the first thing I want you to do is figure out at which x value, a, b, c, d, or e, is our slope, is our derivative, the greatest. Okay, well, I know that any positive slope has to be greater than a negative slope, so I'm looking at either d or e. D looks steeper than e, so d is going to be my greatest derivative. I'm going to start with f prime of d because it's a positive value and it's steeper than what I have at e. Well, I think I kind of gave away what the next one's going to be. What's the next steepest one? F prime of e. Then what? Hopefully you said f prime of c. And actually, I can say even a little more than that. I don't know, by looking at my graph, what exactly the slope is at d. I just know that it's a positive value, and I know that it's a higher slope, a higher value than at x equals e. But I actually can find the value of my derivative at x equals c. What is the value of the derivative? What is the slope of that line that's tangent to the function? Hopefully you said 0. Okay, well, then what? What's the next steepest slope? Well, let's see. Now I'm moving into negative slopes. I have a negative slope here and a negative slope here. This one's shallower, this one's steeper. So this would be like a small negative number. This would be a bigger negative number. We're going to say f prime of a and f prime of b. If we're looking at a graph, the derivative means the slope, but our better definition is the derivative is the slope of a line tangent to our function.